Albert was driving on a straight highway from Edinburgh to Megiddo at 60 miles an hour. Beatrice was driving faster than Albert on the same highway in the same direction. She started behind Albert. She passed Albert at 1:20 p.m. At 3:20 p.m., Beatrice arrived at Megiddo, and Albert arrived 15 minutes later at 4:10. Assume both drivers kept up constant speed without stops. What was Beatrice's speed in miles per hour? Okay, so the first thing to notice, we're not given any times or anything about the starting point, Edinburgh. We don't really care about Edinburgh. What we care about, really, our starting point is going to be the passing point. The point where one passes the other, where Beatrice passes Albert, because at that moment, when Beatrice passes Albert, they're at the same distance from Megiddo. Okay? So they pass, and then they get all the way to the end. All right. Well, the passing happens at 1:20. Then Beatrice, she really drives very fast there. She gets there at 3:20, and so her time is 2 hours. We don't know her speed, we don't know the distance, but that's her time. Albert, he drives this distance, and he takes until 4:10. Well, that's 50 minutes later, so that's technically 2 hours and 50 minutes is his time. But here's the thing, we know Albert's speed. We know his speed is 60 miles an hour. So in the first hour, he went 60 miles. In the second hour, he went 60 miles. And then, since it's 60 miles an hour is a minute a mile, in 50 minutes, he went 50 miles. So 60 plus 60 plus 50, that adds up to 720. That's the distance. That's the distance from the passing point to Megiddo, 170 miles. Well, now we can go back to Beatrice. She covered that 170 miles in 2 hours. So rate equals distance over time. 170 miles divided by 2 hours, that is a rate of 85. 85 miles an hour. Beatrice was really burning it up on the highway, and that is her speed, 85 miles an hour. The answer is 85.
All right, we have a sequences question. In this sequence above, each term after the first is found by multiplying the preceding term by a constant c, such that a1 times a2 times a3 equals 216. Now this problem may look intimidating at first, and one of the best things you can do when you get a sequence question like this is to figure out what the individual terms are first. So let's start at the beginning with a1. That's the first term, so it's just going to be a1. Next up is a2. So a2 comes after a1, so let's multiply by a c. So we can just say a2 is equal to c times a1. Then after that comes a3. So a3 is just a2 times c. And since a2 is c times a1, we can also say that a3 is equal to c times a1. Now let's take the product of all these three terms. We have a1 times a1 times a1, which is going to get us a1 cubed. And we also have c times c times c, which gets us c cubed. And that is going to equal to 216, the same thing as a1 times a2 times a3 here. So now let's look at our columns. We see 6 in column B and a2 in column A. Well, let's think about what a2 is equal to. It's equal to c times a1, both to the first power here. So if we see a1 to the cubed times c cubed, we can get just c times a1 by taking the cube root of both sides. Now on the GRE, you should know your cubes at the 10, like 1 cubed is 1, 2 cubed is 8, and so on. So if we knew that, we could just say that a1 c1 is equal to 6, and the correct answer is C. However, if you don't know that, that's okay. One strategy you might want to use is thinking about, okay, what goes into 216? Well, it's got a 6 at the end, so maybe 6. So if we divide that by 6, we get 36, and then you should be able to recognize, hey, that's equal to 6 squared, so 216 must be 6 cubed. So either way you want to solve it, the correct answer is C.
Let's begin by assigning some variables. We'll let T equal the amount of money that Nina has, and we'll let X equal the current price of one widget. We're told that Nina has exactly enough money to buy 6 widgets. So if we take the price of one widget, X, and multiply it by 6, we will get T, the amount of money that Nina has. Now what if we take the price of one widget and reduce it by $1.25? Well, this makes the new price X minus 1.25. And we're told that Nina has enough money to purchase 8 widgets at this price. So if we take this price and multiply it by 8, we get T, the amount of money that Nina has. Now notice that the left-hand side of both of our equations are set equal to T, so we can rewrite them equal to each other. From here we can solve for X. First we'll expand the right-hand side, and now let's subtract 8x from both sides. And now we'll divide both sides by -2 to get x equals 5. This tells us that the current price of one widget is $5. Now we need to determine the amount of money that Nina has. We know from earlier that T equals 6x. We'll now replace x with 5 to get T equals 30. So Nina has $30. The answer is C. Okay, in order for us to find the value of W in column A, we need to take this equation here and replace x and y with expressions involving W. So we're told that half of W is x, so we can write the following equation. Also, we're told that half of y is W, so we can write this equation. Now I want to take this equation and multiply both sides by 2 to get y equals 2W. Alright, we'll now take the equation we've been given. We'll leave W as it is, but we'll replace x with 1/2 W, and we'll replace y with 2W. And this will equal 28. At this point, we can simplify the left-hand side to be 3.5W, and finally, when we divide both sides by 3.5, we get W equals 8. So column A is equal to 8, in which case it is greater than column B, and our answer is A. Let's begin by noticing that the information provided about each person's contribution is given as some kind of relationship to the total cost of the gift. So let's let X equal the cost of the gift. From here then we know that Declan's contribution will be equal to X divided by 4 plus 4. Ed's contribution will be X over 3 minus 1, and Ed's contribution is 22. So now we can create an equation. We know that Declan's contribution plus Ed's contribution plus Frank's contribution equals the total cost of the gift. So it equals X. From here we can simplify the left-hand side. And now let's eliminate both of our fractions by multiplying both sides of our equation by 12. When we do this, we get the following. And now we can simplify 3x plus 4x to be 7x. Here we can subtract 7x from both sides. And now we'll divide both sides by 5 to get x equals 60. X equals the cost of the gift, so the answer here is C.
On a certain table is a collection of 45 pens of various ink colors and various designs. Of these pens, 60% are ballpoint pens, 60% have blue ink. And so we want to know about the overlap, the ones that are both ballpoint and have blue ink. How does that overlap compare to 8? Let's clear this out of the way so we have some room for calculations. First of all, what is 60% of 45? Let's change this to numbers. 10% of 45 would be a decimal, but let's say that 20% of 45, well, that's just 1/5 of 45, so that would be 9. Now multiply both sides by 3, 60% of 45 would have to be 3 times 9, which is 27. All right, so we have 27 ballpoint pens, and we have 27 blue pens. And we want to know how much could they overlap. Well, of course, they could have maximum overlap. It could be that every blue pen is ballpoint and every ballpoint pen is blue. So we have 27 of both of them. There are 27 blue ballpoint pens. That would be the maximum overlap. What would be the minimum overlap? Well, think about it this way. Suppose we have here 27 ballpoint pens. Well, what are the non-ballpoint pens remaining? Well, there'd be another 18 remaining. And so we could make all 18 of these blue, but in order to have 27 blue pens, we'd need 9 more. And so there'd have to be at least 9. And so this would be the absolute minimum overlap, that even if we're trying to get them as far apart as possible, there would still be 9 pens in the overlap region. So 9 pens that are ballpoint and have blue ink. And so we know the number of pens in the overlap. It can be somewhere between 9 and 27, but if it's between 9 and 27, it's always greater than 8. And so column A is greater.